in Riyadh. So these and Faisal University as well. So there's 3 or 4 MOUs that are also in the pipeline.
Sounds good,
So
Walla. Yes,
uh, so,
nice.
so things are going very well. I'm just going to say Assalamu alaikum to everyone. Noura and Lama, I see you've joined the calls. Thank you for joining in. And I'm just going to start off the presentation in a couple of minutes.
Okay.
So let me just tell you a little bit about what I'll be speaking about today. So today, because we've got new people signing in, so all 3 of you, it's your first day today, and then Azam, just going to introduce him. So he is our AI trainer over here. And then we have Helio Peroni, who's going to be shortly joining in as well. He's from York University, Canada, from the James Elder Lab over there. And then we're going to have a few more people. Aside of us, what also happens is we record these lectures. Oh, there you go, Helio. How you doing? Speak of the devil. I think you're on mute. Couldn't hear you there.
Hello, everyone. Good afternoon.
Yeah, it's afternoon. It's after, well, yeah, it's afternoon. It's nearly evening for us, but yeah, thank you. And how's your morning going so far?
You know, right? When you can lead a healthy life or be the parent of a small child. It's one or the other.
That's very true. So here, for those of you who don't know, Helio is raising a newborn now. Well, he's not a newborn. He's a few months old now.
He's just over a year now.
He's just over a year. Yeah, see how
Just over
time
a year
flies,
old,
right?
yeah.
Yeah, yes, time really flies really quickly. And yeah, I see you're looking forward to the weekend as well. You're not going to York today, are you?
No, I'm working from home today.
Oh, that's very good. That's very good. Okay, so we've got a few people over here, and a few people, they usually join a little bit late as well sometimes, because this course is designed in such a way that it's flexible. So people who can't join in on the call, what they do is then they can go and look up our lectures on YouTube, and then they can go through the session. And Azam and Helio are available throughout the week for any question and answer, so you can always email them. For those of you who don't have their email addresses, I'm happy to share them. And this specific call is an introductory call, so it is a bit different from our regular training sessions. Our regular training sessions, the schedule will start again in 2 weeks from now, because next week we are off for the holidays for Eid al-Azha, and Azam is the one who connects on those calls, and he is the trainer. The previous sessions, so for those of you who have missed the last 4 or 5 sessions, you're always welcome to go on YouTube and look them up. So that's also quite possible. So I'm just going to start off with the presentation today, and then more and more people will start joining in, and that's fine. Azam, if you can start, please, recording too. Aside of that, if I lose power or internet in during the call, I will try my best to get back as quickly as possible. So just a heads up. And I'm just going to start to share my screen. You guys can note down any questions that you may have, and then after the presentation is over, I would like you to come forward with any questions, which I'm happy to answer. And here we go. Okay, so okay, so hopefully you guys can see my screen. And
Yep.
there we go. Okay, so Neurocognitive AI, it's NCAI. It's a Canadian startup. We've been working on developing this solution for about 2 years now. You can always go on our website and check out what's going on, our recent developments, what the product is all about. I'm going to be speaking about it today. Essentially, we're developing an AI-driven diagnostic tool, which is going to help in the early detection of Alzheimer's and other diseases of the brain, including dementia, Parkinson's, tumors. There's 44 types of tumors, aneurysms, but our first and foremost basic focus is on Alzheimer's. We are planning on launching in Saudi Arabia. So I was just telling Abdullah about how our endeavor has been moving forward. So essentially, we landed in February in Saudi Arabia. We were participants of Leap 2025 in Riyadh, which is a technology event. I'm sure most of you have heard of it, and which is where we connect with Abdullah and his team. So that we had a very good event over there, and now what's going on is we're in process of registering the company in Saudi Arabia. We are being backed by the RDIA and the MCIT, but I'll talk a little bit more about that a little later on. Let me first talk about the solution a little bit. So essentially what we're doing is we're trying to harness the power of artificial intelligence in making this a diagnostic tool, which is going to be deployed at hospitals and it's going to be used by health professionals. It is essentially intended to streamline the process of identifying and treating neuro diseases like Alzheimer's. I'm just going to move forward and talk a little bit about the numbers. So what's going on is this, the Saudi Ministry of Health estimates that around 130,000 people in Saudi Arabia have Alzheimer's disease. And that is a somewhat rough approximation or number they've come up with. But we also have to keep in mind that Alzheimer's is a disease which sort of lies in a gray area. So sometimes people have Parkinson's or dementia or some form of dementia or early onset of Alzheimer's. And it gets very difficult for diagnosis to happen. A, because a lot of these diseases have similar symptoms. Number two, there's rigorous testing that's required in terms of MRIs and repeated MRIs and fMRIs. And sometimes it becomes very difficult to take elderly patients to the hospitals, especially if you're living in rural areas, it becomes increasingly difficult. And that is why a lot of these cases slip under the cracks as well. And in society, they usually get labeled as old age related problems, but sometimes it's actually Alzheimer's or some form of dementia. Globally, it is estimated that a person develops dementia every 3 seconds. So let that sink in for a little bit. It's every 3 seconds someone is getting someone is either developing dementia or getting diagnosed with it. So, and Alzheimer's is the most common form of dementia. So that is essentially our motivation. That's why we're primarily going after it. Traditional methods right now, the current state of the art is that doctors rely on MRIs and fMRIs, and it requires patients to undergo multiple tests to assess their brain structures and functions. Then they go to doctors and specialists, and sometimes doctors aren't available, and sometimes there's a long waiting lineup. Especially in countries like Canada, for example, there's public healthcare, and sometimes you need 6 months to get an appointment with the doctor. And then sometimes a lot of the time there's multiple consultations that are required, and sometimes it's very, very difficult to do that. What we are moving towards, our solution, it's going to be faster, it's going to be more accurate, the diagnosis, it's going to be data driven. It's not just going to rely on the doctor or his or her expertise. So it's something that is driven by data and numbers. And what we're also going to do, this solution is going to do, it's going to reduce the need for extensive testing. So that is also very important. It makes it cost effective. It makes it time effective. It saves time. And the deeper statistical and insights that it provides are going to be very helpful in monitoring the patient's health and ensuring that there's precise treatment and good positive decisions are taken to counter these diseases that the patient may have. Just going to move forward, fast forward actually, to our diagnostic panel. So these are the 2 slides for the panel. So you see the panel on the right. Essentially what it does is it's a simple process. A doctor will order an MRI, fMRI scan. So based on just 1 scan, they're going to get the report. They're going to upload the report to our system, and in real time, our system will process it. Now, we have AI-based models and algorithms. Azam will brief you more in detail about those as you attend the sessions and as you learn more and more. But in a nutshell, what's happening is we have a database that we train the models on. We get our data from sources like there's companies in the US that specialize in giving out data for Alzheimer's. So there's a company called ADNI, for example. There's another one called Oasis. And these provide us with state-of-the-art data sets for training and validation. So once we run the patient's MRI or fMRI in the system, it compares it to the hundreds and thousands of images that we have in the database that the model is trained on. So it's machine learning and computer vision based. one part of it. That's the very, very basic essential part that I'm talking about. And if there's a match to an image which was problematic or which was classified as Alzheimer's or early onset of Alzheimer's or aggressive Alzheimer's or some stage of dementia, it's going to red flag it right there and inform the doctor that this is what's going on. Furthermore, our model is predictive. So if it is a match to a MRI in the database, which at the time was okay, but eventually developed or ended up developing into a problematic one like dementia or Alzheimer's, it's going to inform the doctor as well that this eventually developed into something and you're going to have to take a more closer look at it. So what happens then is then there's a report generated, and the results of the report then guide the physician or the doctor as to what's going on. It's based on explanation AI as well. So it's not just going to be a one-word report. It's going to be a detailed report which not only gives the doctor the analysis, but it also gives the doctor the reasons behind the analysis. For example, it matched the current MRI matched MRIs in the database because of such and such factors, or if there was some tissue material that was the same, or whatever the reason may be. And then there's a complete explanation and analysis that comes, which also guides the doctor, makes life easier for the doctor, for the patient, for everyone involved. It optimizes the supply chain in terms of optimizing the clinical workflow and processing more and more patients in a shorter span of time. The user interface is very easy to use. Anyone with basic skills can use it. It also has more charts and graphs, which we are refining at the moment. It's going to show you the doctor, the patient profile, the previous visits, any other information that may be deemed necessary. What it also does is the system, our model, it also streamlines a lot of the process. So, and you're going to learn more about this. I spoke about this in our last session when I gave the presentation on neuroimaging and pre-data processing. So there's multiple steps that are involved that include tissue segmentation and skull stripping of MRIs, and then there's a multimodal MRI stuff over there as well. You can look up our previous lecture on my previous lecture on YouTube and go through it if you missed that one. So usually these are steps which currently neurologists and neuroimaging experts do by using tools, but those tools are restrictive in the sense that you can only do one process at a time. What our solution does is it does 6 different steps in one go, and then it enhances the image, which is then processed through the database. So it's very time saving in that respect as well. It is also very interactive. So there's different angles of the image that are created that the doctor can go through. Doctor can also have a look at the patient profile and the patient history, and a little bit more about that in the next slide. And real-time metrics and trends and flow charts they can go through. So they can assess and visualize how the brain activity is happening and how it has changed over the last 6 months or so, for example. Now, this is one part of it. There's another significant part of it, which is a second model that we call it the Neuro Analyzer. What that does is that it exports all this information from the MRI and fMRI and from over here to that model. And also it allows the doctor to enter qualitative data into that model, and that data will include question and answer results with the patient. So for example, you're going to ask the patient about basic stuff like age or gender or other backgrounds like medical history. Is there medical history of Alzheimer's in the family, for example? That's a very popular question with neurologists, and it's a very important factor in making a diagnosis as well. And other factors like lifestyle and sleep patterns and diet concerns and how's your diet. There's a whole list of stuff. We're going to share that with you as well at a later stage. So all of that information is then input over there along with biomarkers and stuff that you derive from the MRIs and fMRIs. And then that is run with the LLM based at the back. Currently we're using Grok right now, but we are working on different models and so that they can fetch data from not just one LLM, but various LLMs. And after that is processed, then that also provides a report in PDF format to the doctor, and then the doctor is able to assess and analyze based on this report of what's going on and how they can help the patient better. So I just want to keep it at a high level right now, because in consequent sessions, Azam will be going through each and every step with you from a technical perspective, from an AI perspective. But this call is more of an introduction call, so I want to keep it very high level. I'm also going to, yeah, technology stack Azam is going to do as well on his next calls. And a little bit about Saudi Arabia. Obviously, you guys are mostly all from Saudi Arabia. We only have, I think it's Dua who's joining in from Canada, and obviously myself and Helio and Azam who are non-Saudi. But we've got 4 or 5 Saudi people over here, and we have to keep in mind that this program is for Saudi youth, and that's why the MCIT and the RDIA are encouraging us to develop this program further and get more and more people in. With this solution, look, the Saudi digital health market is going to be valued at about $6.8 billion by 2030, and that's the Vision 2030 program that we're targeting. So we aim to target hospitals and diagnostic clinics with this solution. It is going to be a first to market advantage for us, because there's nothing out there in the market at the moment that is dealing with Alzheimer's, or is focusing on early prediction of Alzheimer's. So I think it's a tool that is very innovative, and that's why we are getting support from hospitals and universities in Saudi Arabia. A little bit more about that a little later on as I move through the slides. Development, yes. So we've trained the Alzheimer's model. We have accuracy of more than 95%. It's actually 96, 97% right now, and we're refining it further. We also aim in the future to tackle tumors and aneurysms and other neuro problems, but right now the focus is on Alzheimer's. Now, from the business perspective, what's going on is we're in process of getting registered in Saudi Arabia, and the RDIA, the Research and Development Innovation Authority, is endorsing us. They're giving us a letter of endorsement, and they're helping us in getting registered. We are a part of their attraction program, so that involves them giving us office space as well in their buildings, on the premises. And they're going to be advertising our company on social media as well. So we will be able to use currently they are reposting stuff for us as well, but during the course of the summer, as the registration for the company goes through, it takes about 3 months. You are going to be seeing more formal collaborations and MOUs that are going to be signed with the RDIA and MCIT. Also, we have gotten the green light from hospitals and universities like King Faisal Specialist Hospital and Research Center, for example. So that's a very big hospital in Saudi Arabia, as you guys know, and they are going to be collaborating with us formally via a MOU in developing the solution. We've also got universities like King Saud University on board. We are going to be running an AI training boot camp for them in September. So we will be leading that as well. We've got also interest from universities like Al Faisal University and KAUST out there in Jeddah, King Abdulaziz, Science and Technology. So things are going well on that perspective as well. Now, what you have to understand is why we are doing all this is we want to, number one, we want to build an R&D platform which has all these professionals from hospitals and universities and people that specialize in neuroscience, neurology, and artificial intelligence and computer science, because we want to validate the product with them, with their consent. It should be developed with their cyclical feedback, and all the iterations should be based on their feedback and their reviews. So that and I'll tell you why, because these are the people that at the end of the day are going to be using the solution. So it only makes sense that they have a say and they have a hand in developing it. So we aim to provide a collaborative R&D platform for all these people to come together. We want students to come together. We want students to be part of it in terms of training programs, internships, co-ops, even work placements in the future. And then we have all these people from Canada, from York University. We have Helio. He's from the James Elder Lab over there. Helio and myself, we've been working together for the past 5 or 6 years, 7 years. And we want all these experts to come together so that they can share their knowledge and somehow contribute to the solution. Even if they're not contributing to the solution directly, they should be able to be in a position to get training from our programs to further their own careers. There's a lot of connectivity. You can join our LinkedIn. There's a lot of people in our list who you can follow. We've got people from Saudi departments, government departments, private entities, and especially for you new graduates out there, I think it's a wonderful opportunity for making new connections. In terms of our roadmap, this solution, this idea came along in 2022-23. We've been working on other projects as well, which we will share later on. And then we started developing the models and the algorithms, and we hope that with all these Saudi partners, we can further the R&D, refine the solution, and deploy a test pilot sometime this year, inshallah, and then look towards commercializing the solution in coming year 2026 and 2027. Now, in terms of the collaboration, like I said, the kingdom is buzzing with energy right now. There's a lot of investment in AI. People are focusing on healthcare and technology, and we are right at the intersection. We are focusing on neuroscience, and we have AI as a weapon that we're using to address this problem of catching Alzheimer's early. We've got academic integration in terms of partnerships with the universities and as along with hospitals and neuroscientists. We aim to empower the Saudi talent in terms of training. Now, all our training is absolutely free of cost to join. So tell your friends as well. Again, this specific session, don't judge us by this session because this session is an introduction. Our technical training you can assess via our YouTube videos so far that we've uploaded, and the following sessions that you're welcome to attend. Sessions are once a week, and then that session is usually 60 to 90 minutes in length, and it's a very interactive session, and you can always bring your problems of AI to us, and then we'll help you as best as we can. We've been helping students with the thesis and stuff as well, so you're always welcome to ask us anything. If you have working on any projects, you need advice with those, you need help with those, you can always reach out to Azam, myself, or Helio. We're always here to help you. And it's a community outreach. We're capacity building from a strategic perspective. We are looking to move forward and integrate in the Saudi market. Again, our plan is to get registered this year. We are looking for investors as well, Saudi investors, and we are in discussions currently. We're looking to hire up to 15 Saudi nationals by the end of year, hopefully, inshallah, if things go well, because our plan is we want the solution to be built in Saudi Arabia. It is going to be built by Saudis. It is going to be used by Saudis. And as I said, we're signing R&D joint venture agreements with universities and hospitals. One more thing is we've been requested by King Saud University to look into developing a neuroimaging lab, AI lab at King Saud University premises in Riyadh. So we are looking into that and how we can use it. It's going to be a great thing for people who are then going to have access to the lab, and they can use all those facilities and use it not only to develop this solution, but to use AI and develop other solutions, innovative solutions as well. And these are the agreements and the MOUs that we are working on and which are going to be materializing during the summer. This summer, as I said, we were at LEAP 2025. Abdullah was there as well. I don't think we see Abdullah in this video, but well, we see Abdullah, His Excellency, the Minister for MCIT over there. That's Mr. Abdullah Al-Swaha. And the tall guy over there is Mr. Ibrahim Niaz. He's the CEO of NTTP. So these guys visited our startup pod over there, and I showed them the solution, and they were very happy with it. I'm going to run a very short video over here. So that was a very good point, a good highlight of the event, and it's not just these people, but we met a lot of other government representatives from other departments as well as like the Ministry of Health, for example. They sent their representatives too. And as I said, this aims to be a collaborative venture, which aims to galvanize the Saudi talent and talent from Canada and bring all these researchers together. A little bit about our training program. So that's Asma. She's not on today's call. She's traveling. So we have 2 or 3 people who are going for Hajj right now, so they weren't able to attend. But as I said, this internship program will impart training to Saudi youth, and it is open for anyone who wants to join. If you have a background in medical sciences or neuroscience, you're welcome. If not, you're still welcome. Computer science students are welcome, AI students, and anyone who wants to join in. We've got people joining in from a business development perspective side as well, in the sense that we've got people in here who want to be PMPs, like project management professionals, and they want to use the experience for gaining experience in project management. So they're also welcome. We've got people from York University to guide us as well. And a little bit about myself. So I've been working in Canada in AI projects. Most of the projects that we've worked on are manufacturing sector, supply chain optimization projects, industrial manufacturing projects. So, for example, we've developed quality control systems for different companies, like the companies in the automotive industry. We did a project with the Toyota Canada a couple of years ago. Healy was a part of that project as well. We developed a really cool project that we did was we developed autonomous robots, which are disinfection robots during COVID-19. This was a part of the Canadian government's response to COVID-19 and bringing people back to public spaces after the pandemic ended. And then there's Helio's profile over there. He's very, very experienced in AI. He's done a lot of projects, and anyone who wishes to reach out to him directly is always welcome. We've done other projects as well. We've done retrofit kits for forklifts, for example. We've done quality control systems for other companies. And yeah, that's about it. If anyone wishes to reach out to us, they can always email us or visit our website. I'm sure most of you have my personal email as well. And now, before I take further time, I'm just going to hand it over quickly to Dua. Dua is one of our rising AI interns, and she's going to speak a little bit about what she's been working on. So over to you, Dua.
Hi, everyone. Thank you for passing it to me. So I'm a third-year computer science student at University of Alberta, now going into my 4th year. So I major in computer science, but I'm pursuing a double minor in bioinformatics and statistics. So this is perfect for me because it's the perfect intersection of what I'm doing at university. So I'm just going to share my screen and show you guys what I've been working on. I'll start off by showing, there we go. Yeah, showing my GitHub repository. I created this because I think it's a good way to keep organized, and it's a good way to basically just have all your code in one place. And I'll share a link to this in our WhatsApp group, and then anyone who wants to practice can just use this as a tool. I'll just give you a little overview of it. This repository just right here shows an overview of all the different things in it. I have a few files. They're very basic, and I'll demo them in a moment so you'll get a better idea of what they contain. I also have a requirements file. So what I would recommend doing if this is your first time doing neuro imaging is maybe you could download this, you could download this Git repository and then open it as a project folder on maybe VS Code or something. And you could, the reason why I have a requirements file is it just has a list of all the packages that you might need for neuro imaging. So if you use my example to get a hang of neuro imaging, what you could do is open this project folder and then run a command. I have it written here. So this command would basically just install all the packages that are listed in this text file. And it's a very basic thing, but I just think it makes things a little easier as you move forward. I also have a link to a Google Drive. This link is just a link to a data set that was collected by, I believe, the pediatric, they're called the Pediatric MRI Collection. And it's very interesting because they it's basically just a big research project that collected MRI scans of healthy children and teens as they were growing up. So over 500 kids were part of it, and the goal is to understand how the brain normally develops from infants to young adults. And their data is open source. So I have a link to it here, and this is a great tool for practicing because it has a lot of nifty files, which as I continue my demo, you'll get a better understanding of what that is, but that's the format that MRI scans are in. So because there are so many files, you have a lot of different opportunities to practice, which I think is usually the most difficult part when you're coding, practicing, because it can be a little daunting at first. But what I've done today is I've just broken down the code that you would need to load MRI data and to view MRI data. So hopefully that will make you understand that it's actually not that difficult, because I'll just be explaining what everything means, and eventually as I move forward, everything will just become really repetitive. So let me just open that and I'll demo it. Okay. Yeah, so I have 3 files here, and I'll just show you what it looks like. So,
I'm sorry. Are we supposed to see a different
yes,
different view
yes,
than
yes.
the README file?
Yeah, sorry. I guess it didn't update.
Yeah, you probably shared
let me
the
just share it
tab,
again.
Yeah.
Yes, there we go. I just moved to VS Code, so I hope you can see that now.
Yes, thanks a lot.
Okay. Yeah, so I'm just gonna go through a little demo of this just to explain all the code, and then that'll just give you an idea of everything. So we start off by loading our packages. So the first package that we use is just to view our MRI scan, and then we import a few other packages that would help us work with 3D scans. And then we move on to importing Matplotlib, which is what we use to actually view an MRI scan in like different slides. That just helps us make sure that we can look at the MRI scan in a way that's like comprehensive. Here we would load the MRI scan and then load the shape of it, which tells us how many different slides comprise of the scan. And then we move on to importing our libraries again, and then we import something called an int slider. This, I will do my best to explain it, but I feel like when I eventually run all my code, you'll get a better understanding of what that does. But essentially, it will print a it will print an interface that would that you would be given a slider, and then as you slide through it, you can see multiple images, multiple slides of the MRI scan. And then I defined a function here. This function I defined, if you guys are familiar with Python, you would understand, this just breaks down, so functions just break down the process. So instead of having to do the same thing over and over again, you would have a function that would just load the MRI scan. So, yeah, and then moving on to this part. This is the part that just plots the slide one by one. Okay, sorry, just one moment. Yeah, so this essentially, what this does is it lets us look at one slice of the brain. So you could imagine the brain as a stack of paper, and this specific function just helps us look at one slide specifically. So if this is a little complicated for you, let me just break it down a little bit. It selects one sheet from our stack, like I was talking about, and it flips it so it's not sideways. It also makes it black and white, like in real MRI scan. And then just a few extra things. It hides the graph lines and it just shows us which slide we're on and displays it, right? And now we move on to the interactive viewer that I was talking about. So this is what makes it kind of fun and interactive, because now we're adding a slider so you can scroll through through the brain like a flip book. That's what I like to think of it. Now that we've defined the functions, this part helps us actually view that slide. So let me actually run it, because I feel like it would be better if I ran it. Yeah, this number here is very important because it tells us how many slides we have. And then it defaults to the middle. And this, by the way, is just a nifty file that I got from my repository that I was talking about earlier. So this is the slider here. And let me just flip through it. It's actually very cool. So when I flip through it, it just builds an image and it's very cool. So this is how we load our data and view it. And I'm going to move on and show you many other things that will just give you an idea of how repetitive and simple it gets once you actually understand the code. Okay, so now this part in particular, we load our file again. Again, we do the same thing that we did before. We load the shape of it. And here, this specific code just goes to the very middle of our, this is just the very middle slice, so somewhere around here. So that's exactly what it's printing. And the reason why they look kind of different is because this black and white one is flipped. Now, I'll show you something else. So this part is a little different, because what this part does is it loads and loops through all the slides. So all the different slides that we have here, this part just loops and prints all of them. So I have a bunch of them, And if you look on the side here, it actually gives you an option where you can either copy an image, or you could expand the image. You could also save the image. Now, if you want to download all these images, which some people might want to, and if you wanted to look at all the images and analyze them, or whatever you wanted to do with them, it would be kind of inefficient to have to download each image one by one, since we have like 190 different images. So then we can do something else. What we can do is write a different code that would help us save all the slides. And it's very simple, actually. If you were paying attention when I was explaining this, then you would know what this means. The first package that we import just makes sure, just reads our nifty file, our MRI scan. This would help with our 3D array, which is our MRI, like in numerical form. Matplot, again, is used to display. And then CV2, this might be a little new, but this is what helps us save everything to JPEG. So again, same thing, we load the nifty image. So it's the same thing that we've done before. And then we use test underscore load to get the actual data of the image. And then this part here is just like a test that we can do just to make sure everything is running carefully. This part the second cell just loops through all our slides. So here we had all our slides and we printed them, but here we have all our slides, but we're deciding to actually loop through them and then save them in JPEG form. So now I'll run this and I'll show you what it looks like. Let's run it. And hopefully it works. Okay. I don't know. Oh yeah, there we go. Thank goodness. So as you can see here, I don't know if you looked at this, but when I was learning how to do this part I really wanted to understand what this meant, and it's pretty simple. We'll get to this in a moment, but an MRI scan is 3D, of course. So here you have an x-axis, you have a y-axis, and then you have a z-axis. And this is, the z-axis is the view from the very top of the brain. So I have 65 here because this is this is slide 65, and you're viewing the MRI scan from the top. And then this didn't show anything, but I'll show you what it ran. So this part just saves all our JPEG images, and this is what it looks like. So once we run this loop, all the images that we saw here just get saved into a folder. And I'll open a few to show you what they look like. Let's open 65. Yeah, look, it's the same. This one's black and white, but it's the same image. And yeah, you can open all of them. It looks exactly like the slider that we used. And if you get an idea of how to work with Matplotlib, you can a lot more other features, nicer, up to you. I like it black and white because I think they just look cleaner. And then obviously we're looking at an MRI scan, so we have to view it. We need to have a 3D view of it. Now what I mean by that is, I think this is the coolest part. So again, this is probably the same thing I've been saying over and over. We import all our packages like before. So now you're probably starting to find this kind of repetitive. And I think by the time you get to this part, you kind of understand that in your imaging, especially when you're starting off with it, is all about practicing and really understanding what the code means. Because once you have an understanding of it, the rest of it also becomes less challenging. So again, imported the packages and we loaded our image. So now we can move on to actually building a setup for our 3D view. So again, load all of this, and then define a function. And now in this specific function, what we're doing is we're defining all our different views. So we start off by setting a default view so that when we run our code, the slider will be set. So again, we're using the same slider that we did earlier. So when we run our code, the slider is set to a specific image. In this case, it would be set to the middle image. And since it's a 3D view, we create 3 side-by-side plots, one for each view. So then we do that here. And then we do the same thing for our x-axis, our y-axis, and our z-axis. If you can see, they're all very similar, but there are some differences, so I'll explain that. So the x-axis is like viewing the brain like from, I guess, like the side, I would say. And like we would differentiate our code. So slice, because this is the x-axis, this is where slice x would be. And yeah, and then we show the slice number and how many total slides there are in that direction. And then we also draw axes, which would show, which would mark where the other views intersect. So in this case, we would use a red line to show where the y-axis intersects and a blue line to show where the z-axis intersects. Again, do the same thing for the y-axis. So the y-axis shows, it's like looking at the brain from the front. So it would show your vertical axis with lines intersecting where the x and z slices are. And then the axial view, the z-axis, which we've been seeing here, is like viewing the brain from the top. So again, it's the same thing. This thing would change. So we talked about this earlier as well. So as the views change, we would have to put our variable in different spots so that like it understands that we're doing something different each time. Again, define the interactive viewer so that this would just help us when we're running our code so that it's easier to understand. And then this specific part, what it does is it actually connects our interactive viewer with all this code that we've written here. So that whenever the slider changes, again, it'll be better when you see it, but whenever the slider changes, the plot itself will also update. And yeah, so the sliders they basically just let us move through the brain along the Y, the X, and the Z axis. They go from 0 to the very last slice, and they start in the middle. Okay, and then this part is what actually shows the slider. But I have a little if statement here, and which just loads the data and checks if it's 40. If it is 40, then it only takes the first volume. And then we launch the interactive viewer with 3 sliders and 3 views. Okay, so now I'm gonna run it just to show you what it looks like. So yeah, obviously this runs nothing. It just loads the image. This part just sets up those sliders. So this one would make sure that it's set up at the middle image. And then this is what actually focuses on the individual views. And there we go. So like I mentioned, we're at the very middle. That's what that was doing. We also have our blue and red dotted lines that show where the planes intersect. And I can just slide through them. And so yeah, this one's a side view. This one, okay. And then this is the coronal, so it's the y-axis, and it is from the front. So there we go. Very interesting. And then you can kind of see, so this here is the side, this here is the front. So you can kind of see what you're looking at each time. And then this part that's protruding out can be seen properly in the axial view here, in the z-axis. So very cool. So I can just slide through. This obviously looks familiar because this is what we were viewing when we were loading our data. But yeah, you can see all the different components kind of like separate, which is very cool. Like something that you might see in this image, you can see more of in this image, and then you can see even more of it in this axial view. Yeah, so what I've done is, I don't know how to get rid of this. I'll go back to my GitHub, but what I've done is, let me go to my GitHub again. Yeah, so what I've done here is, if you go to my GitHub, again, I'll share a link to this so that everyone can use it. And now that I've done my demo, hopefully you can see how it's actually not that difficult. And the most difficult part is starting. But now that I've explained everything, hopefully that gives you a better idea that most of what we do is pretty repetitive. And there is a bit of a learning curve, but once you get around that, you're basically just doing the same thing over and over again. So if you want to practice after the session, what I'd recommend doing is, here you have an option where you can download zip. So this would give you like a compressed folder which you can extract and open it in VS Code or your text editor of choice. I just really like using VS Code. Maybe set up a virtual environment. It's very easy to do. There are countless tutorials on YouTube. So yeah, follow that. It takes like 5 minutes. So once you open your extracted folder in VS Code, you'll have access to the requirements file. You can use that and hit this command. I don't know if you can see that. Okay, you can't. Okay, never mind. But the command basically is pip install -r requirements.txt. I'll send it into the chat. That's all you run, and that just downloads all these packages here. And these are enough to get you started, and then you can add more as you go on and hit that command again. And then you can download a file from this folder here. So open the link. You have countless nifty files that you can you can use. So you can go to load data and yeah, and then in this little section, you could put your file of choice and just run everything. And one thing that helps me understand when I'm practicing is I like to change different things. So you see this test underscore load dot shape. What this does is it prints the axial view, the middle slide of the axial view. So what you can do to experiment and to understand is maybe put this, I don't know, in the middle. So where the y-axis would be or where the x-axis would be. And that would just give you a better idea. Maybe change something else. Just if you keep interacting with it and changing things and maybe running into errors, and then if you're focused on fixing those errors, and eventually you'll understand the code better. And yeah, and then if you think there's anything else that I should add to my GitHub repository, I couldn't really think of anything else. But if there is anything that you would think would be useful for beginners, then let me know. I would love to add it. And yeah, that's it. Does anyone have any questions?
I think Helio has a question. Helio, go ahead.
Yes. Hi, Dua. Thank you very much for your presentation, for your work with this repository.
Thank you.
First, one suggestion.
Yes.
It's common practice in projects that use Python and use PIP, right? The pip tool to install the requirements, to have a line in the README
Okay.
for running for installing the package in the requirements.txt file. I would suggest adding that.
Okay. So
Since your repository is aimed at beginners, maybe you could do a more complete step-by-step mini tutorial on how to set up your environment, right? Make sure that you have the PIP and maybe the virtual env environment, the virtual env package installed as well.
Okay.
And use the virtual env, right? It's a very useful tool in Python that allows you to compartmentalize different virtual environments, so you can have different versions of the same package across in use across different projects, right?
Yeah. Perfect.
I tried accessing the data in your Google Drive volume, but I got to a page saying that I need access. Is this
yeah, you know
purpose?
what?
Is the idea that we should request access before
Yeah,
getting
well,
the data?
you know what? That's something I was kind of unsure about, because this data, like, it seems to be confidential, but at the same time, there was just a link to it that I found on Oasis. I was able to just like click a link, and it took me to a website where I was able to freely download the data. So that is what I'm unsure of, because it would make more sense to have that data restricted. But the people that were, in charge of that data, they kind of just had it lying around. So I wasn't too sure what to do. But yeah, maybe what I could instead do is share a link to where I actually got that data from instead of,
Yes, I think that would make a lot of sense, yes.
Yeah.
Okay, thanks, guys. And Muaz, I think you have one more question.
My question is not specifically catered towards her, but more about the courses. So from what I understand is that it's 6 months, right? Is there a way to compress that 6 months into a shorter timeline?
Yes, it's essentially supposed to be 6 months, because we have two course outlines. We have a course outline for computer science and AI, people with computer science and AI backgrounds, and then we have a course outline for people with a background in medical sciences, like neurology. And what we're sort of doing is we're sort of mixing the two and going forward in that manner. I suppose there is a way to compress it, but it really depends on which area of specialization you want to focus on. So if you can please email me or message me directly with what you have in mind, which area you want to focus on, I can put you in touch with Azam, and then Azam can devise something for you and walk you through. But yeah, it's doable. It really depends on what you want to do and how much you want to do, and then what time frame. So yeah, we could work something out. Sure, just message me directly.
All right, thank you. Thanks a lot for the comprehensive presentation.
You're welcome. You're most welcome. Sorry, my mic was off. So we're running short of time here, so we have about 4 more minutes. So I'm just going to quickly wrap up. If you guys have any more questions, you are most welcome to reach out to me privately, and then I can connect you to the right person, whether it is Elio or whether it is Azam. Azam's the one who's handling more day-to-day stuff. So we can always accommodate you guys. Again, we are very flexible. We upload all our lectures on YouTube. If you miss a session, you can always go back and rewind it and see it. And we're happy to accommodate people from computer science and AI backgrounds, as well as people from a medical background, from neuroscience background, or from any other background. If you want to assist me in the business side of things, that's also possible. If you're pursuing a project management professional designation, we'll help you. I think it's a good platform. It's a learning platform. It's a platform that promotes connectivity. You can socialize. You'll make connections over here. So please don't forget to add us and like us on LinkedIn. Helio, I know you and I were supposed to have a conversation about the neuroimaging lab, but let's move that. I'll call you privately, maybe tonight or on Monday, whenever you're available, and we'll talk about the King Saud University stuff then.
All right, perfect.
All
Yeah,
right.
you can call me either. Let me just give me a second to take a look at my Monday schedule. I think I have a meeting around 9 on Monday.
Okay.
Let me see. Yes, exactly. I have a meeting around 9, but anytime after it would be 5 p.m. Saudi Arabia time. Uh,
Okay. Okay. Cool. I'll
it would be
link
all
up
right.
with you, and then I'll message you. I'll set up a time, and then we'll have a quick chat then.
All right, perfect.
Perfect. And thanks again, everyone, for joining in. It was a good turnout today. We had about 15 people, so that's good. We ideally want to increase it. And thank you, everyone. Again, please add us on LinkedIn. Feel free to message me anything you guys like to ask me. That's fine. And for those of you who wish to get added to our WhatsApp group, I think that's also recommended. So message me. And next week is off for Eid al-Azha holidays, and people rejoin the week after. And inshallah, see you guys then, and have a great weekend.
Thanks a lot.